Hi everyone, welcome to day 20 of SQL Fundamentals. As I have mentioned in the day 19, so today we are going to go with a use case implementation. We learned many things, joins, union, variables, functions, stored procedures, many things over the last 19 days, right? If you haven't watched this video, please click on the playlist on the right corner and you can watch those videos. So today we are going to go with the use case, and this session I will be covering how we would design the tables and how we will define columns, relationships all between these objects. So let us read out like what our customer require, right? A banking company, they want to track the customer savings loan account while ensuring the data integrity, enforcing the necessary constraints. The system should store the customer details, account details, and transaction records while supporting the secure data management calculations. In order to have this task a little easier, I try to add more details. So usually how it works in IT is like somebody will have very high level requirement, as I mentioned in scenario. There will be back and forth discussions to understand what they need. Based on that, we might use any of this project management tool to convert that into user stories and all. So here we are not going to use any tools, anything. All we are going to do is like understand their requirement, think through. So what I want you to take away from this video is like how you have to think when somebody tells you a requirement, how you convert that requirement into our database objects, view, stored procedure, whatever it required, right? We would be thinking that lines and understanding what we need. So here, their one requirement is they wanted to capture the customer information and also different types of information they wanted to capture, and they also wanted to capture the transactional details like somebody deposits the money, withdraw the money. In case of loan, they are making the loan payments, right? All these things, and they are also expecting the interest calculation and posting. That means like they want the interest to be calculated and stored like added as a balance, right? Like it's like a deposit. Suppose if you have some interest calculated every quarter, that would be deposited into your account. And they also expect balance needs to be updated for every transaction. If somebody withdraw the money, there should be balance should be changed, and if there is somebody like deposit the money, balance should be changed. So this is the very high level requirement. So when we read it, we know that 3 and 4 required a different database object. So in this session, we are only going to cover what are the tables required and what are the columns required and how we are going to design, right? So I have put this information into a Word document. So let me tell you like how I think when I get this requirement, right? Okay, so they said they wanted to store customer information. Yes, they wanted to store account information. They wanted to store transaction information. So what are the tables required? So we are covering only database table design today. Okay, what are the tables required? They wanted to store a customer info, right? So we definitely need customer table, right? Customer table. They wanted to store account info. So can we store this account information into same customer table? We got to start thinking that way. But they have mentioned they will have different type of accounts. They will have savings, loans, that is all mentioned. But there will be different types of account. It will be associated with the same customer. So if you are trying to keep customer name, phone number, and all this information in and account information also in the same table, right? If one person have savings account and as well as loan account, he has to have the same information, the name and email ID. All this information need to be duplicated, right? Or in another way, one customer will have many accounts, so this is not a good practice to have customer and account information in same table, because there will be a data redundancy or duplicate of information would be captured, because you will have name and address to be like name and email id, all these things to be duplicated for every account information. So I have decided that I can have a different table for accounts, because then I have to link that to the customers, then only I will know which customer has which account, right? Now they have said you need to have transaction details. So what do they need? Transaction, they wanted to know like each information about deposits, withdrawals, loan payment, loan closure, all these details, right? When you take a savings account, you have one account and you are going to make multiple transactions on top of that. So you cannot keep the transaction information in the account information table, right? So we concluded that transactions, you can name it anyway. Okay, if you have some standard to be followed, we can do that. I'm just keeping, these are my logical thought process which I'm telling myself. I need to have uh, I need to have like three tables: customer, accounts, and transactions. So before I go into the columns, I know uh, cust- okay, or will sorry, or will go into the same order. I don't want to confuse you. Now we understood that we have three tables required: customer, account, and transaction. So what are the columns customer required? Right? Let us dive into that. They mention a couple of columns: first name, last name, email ID, and phone number. Let us capture that first. First, first name, last name, email ID, and phone number. These are the columns required. But how do you uniquely identify a customer from this, right? You may have the same name and last name somebody. You may have email ID. Email ID and phone number can be changed over the period, right? So it is good to have a customer ID column. This is not requirement from customer, but like requirement from the user, but we are defining with our thought process that we need some key that help me to uniquely identify these customers every time. So that help me to connect to the other tables, right? And I also decide, so this is the banking system, I need to know when these customers are created, right? So I'll see um, a date column, create a date, or I can have log date or whatever, right? So this will help me. So here we are not considering the scenarios of like closing an account. All these things are not covered, or closing a customer, nothing like that. So we are keeping it simple. My goal here is to make you understand that how this design thinking, how you will end up creating the table based on the requirement listed here, because they haven't told you what data type, what is this, and everything, right? We are going to understand, analyze the data, and coming up with a entire create statement in the SQL window. That is the conclusion of this. That will be the conclusion of the video. So I got this customer information. I am sure that I captured all what customer need. I also set a primary key. This is going to be my primary key because this is what somebody the column which helped me to identify uniquely. This much information I got, and I'm going to do this for accounts. So what accounts required? You need to need type of account, right? And balance, because they mention like you need to capture the balance somewhere, right? Record, so what is this? Type, interest rate, balance. Type, balance, interest rate, and as our standard we will say create date. We wanted to know when this is created, and we also wanted to have a unique ID for the account, right? Do you agree to that? Yes, right? This is going to be the key help me, because one person can have multiple SB accounts and all these things can be happen. So you need to have a unique ID. Also, you should be able to link these into the customer. So I wanted to have the customer id also in this table, and this is going to be applied as a foreign key to the customer table, right? Customer table, because I wanted to have every account should be linked to a customer. You should not have a account without a customer. So customer id should be linked, sorry, account should be linked to the customer id. That is why I added a customer id. Type of account, balance and interest are from business requirement, and we added an account id and created because like I wanted to capture when this is created. So now I'm telling the transaction table, transactions. So you need to know um, which account this transaction is made, right? So you need account id, you need type of transaction, you need amount, right? What is the transaction, and you need to know like when the transaction is date, or right. So this much is the minimum requirement. If let us see if customer have any another requirement. Record all the deposit, withdrawal and loan. We need type of transaction we capture, right? Yes. So this is all I need, and account ID is unique, right? So that like however we are not referring customer ID here, account ID will help us to roll up back to the customer ID. Okay. So this is defined, and here account id create a foreign key to accounts table, right? So this is the relation. I think I don't need to tell you again what relation is made, because over the discussion we have already made the relation, and it is it's going to be one to many. You will have one customer will have multiple accounts, so that is one to many, and here one account will have multiple transactions, so that is again a one to many relationship. Okay, and what is the valid data type I should apply, right? Now I have this data, so I know like what are the tables and what are the columns, and now my question is like, okay, what is the relevant data type based on the requirement, right? Okay, amount, so can we use money or decimal? It's a numeric column. Transaction date, it can be date. Account id, it is an id and can be used as int, right? These questions and these definitions are the next item which we need to define, and we have first name, last name, they are varchar. That is your thought process. I'll go to the query window when I already have the query written for the same thing. So there which I will be telling you how I have end up creating all these data type. Okay. So next thought process is data type, and what are the constraints to be applied, right? So, or do we really need a constraint? Few columns here which we have defined, right? I need customer ID cannot be null. Customer ID is mandatory anyhow. Since we are setting the primary key, we don't need to worry about all those constraints and applied. First name can be blank, no, so it should be not null. Last name can be blank. If you think yes, then it can be nullable. Email ID, if you think it's mandatory, it should be not null. And phone number, if it is mandatory, it is not null. Created date is our value, so it's not a customer input. So you can still say that it shouldn't be null. Yeah, so and type of account should be mandatory. Most of the columns look mandatory because we kept our table design as precise as only the required columns. So most of them are going to be required here. Balance should be money or decimal, and interest rate is going to be again decimal with precisions. So there are different options which we can define based on our like knowledge and experience and all these things. But understand at least on a basic what kind of data it's stored, and that is how the data type defined. Interest rate, like you cannot have a SB interest rate of 25, 30, 40, right? So you can keep that number between maybe 0 to 10 or 0 to 20 or something like that. So that check constraint can be applied. And type of account, like right now we have only savings bank and loan accounts. So we can decide like which of this data type is has to be like which are the allowed values in this type of account. That can be a constraint. Okay, so hope this is clear in a theoretical manner how you can think from top, like what are the table, and see like if you can capture everything into one table. There, when you think of that, you need to apply the rules of normalization. I have never covered anything on the normalization theoretically, because that's a lot of complications if you don't talk about objects designing, and but talk about normalization is complicated. So keep this in mind, very, very simple role. Don't go deep into everything. There should not be duplicate data. You should be having a uniquely identified, and you have to apply. If there is a customer ID and he has multiple address, it shouldn't be like, okay, I have 10 address, 10 column should be created. No, right? You should be able to add it as multiple rows. When you add multiple rows, you are going to have multiple times you are going to duplicate the same name. So there you are like wasting the storage to store the same name 5-10 times. So segregate that into a different table, use an ID to relate to that, right? So when we keep doing this exercise, right, you will learn more about that. So let us move on to the query window and see like what are the tables I have, the table script which I created, and how that is aligned with the thought process which we built here. I have my query window here. So as I said, my first table is customer. You can see the code is already there. So we'll talk through, and we might be changing things in data types, columns, everything here based on the discussion which we are going to make here in the upcoming few minutes. So first table, we defined it is customer table. Customer ID, you know why it is, and ID, it is not a user input. This is an automatically identity number. So we set a identity. There are two values, right? 1 comma 1. So one is where this ID starts, and second one is like what is the number increment. If like after ID 1 is inserted, should this be 2, 3, 4, right? So what is the number to be added to create the next custom ID automatically? And you also know like what is scope identity, added identity, that help you to get you the identity value after inserting this, right? So we'll be using those information probably in this next sessions and all. First name, we said that it shouldn't be not null, so we set it as not null. We believe that a name of a person can be less than 50 characters, that's why we set 50. And last name, we decided that it can be null. It's not necessary to have a last name in all the users coming in, so let us set it. Email ID, we set it varchar of 100. You can even keep this also varchar of 100, no issues. You know that varchar is variable character, and how that is working in memory we discussed in our data type session. So you would be able to, varchar length is not a key factor in the performance, but it is good to keep the length based on your requirement. Somebody should not simply put a very long value which is not relevant for a name, right? And email ID, I set a constraint that is unique constraint, because I know that same email ID cannot have for multiple people, right? Less of a scenario. Maybe so that is why I said, okay, it should be unique. So I set a unique key on top of it. I have phone number, which I set as care of 10, right? And we all know that phone number is a number. Then why did I say care of 10? Because phone number is a fixed length character, right? I'm talking about this. The expectation here is like mobile number without country code. So that is a 10 digit character. And it is like, why I didn't use int or begin, because int is not going to store you like 9090 kind of number, because it has a limit, and it is a numeric. You are not going to apply a numeric operation on a phone number, right? So it has to be care. You may have questions, you can comment there if you think like, okay, why can't we use big in there? We can talk through, but keep this from my theory. Keep this in mind. You have to use numerical value when there is a numerical operation can be applied on a data, or maybe if you think there is an incremental and all these things are happening. Phone number is a fixed length. Length also matter. Fixed length, fixed value. And so that is why I use char. And create a date, so which we need every time the customer is created. We don't want anybody to insert that. I can say a default constraint, inside the default value is get date. So whenever there is an insert happening on this customer ID, customer table, this is going to create a insert the value as default current time. And if you can also override this value with whatever value you wanted to insert, but if you don't pass that value, it will be taking the current value. So I'm creating this table. Yeah, that created. So our customer table is ready. Now we have account table. You might know why this accounts table is having an error, because we already have an accounts table, which you may have remember. If you have followed my previous class, we had an account table which we used for our transactions and all. But I have renamed here. This is not reflected in this query window. That's it. So you can rename or drop our old accounts table. So here I have account ID, which is primary key. Here I said account ID should be starting from 1000, not from 1. So that means my first account ID is going to be 1000 and it will be incremented with 1. And customer ID is from my previous table, which we discussed. And I am also setting a foreign key constraint of references to customer ID. And I can see something which is mentioned interesting. I think foreign key, references, customer ID of customers in customer ID is also clear. What is this on delete cascade? So on delete cascade is nothing but if I delete a customer, it also delete the account information of the customer without even triggering the delete statement. We'll try that practical example, but on cascade we have different like on delete, what action you have to do, those kind of things are there. On delete cascade is going to delete the data from accounts table if you delete the particular customer from the customers table. And account type, I said varchar of 10, and I am also making sure that there is only 2 accounts type. I'm setting a check constraint, so that is like either it should be savings or loan, and it shouldn't be null, right? Balance, we said decimal. If you want, you can set money. So we have a money data type. And interest rate also you can set it as money. So I kept it decimal because the decimal is not wrong. So I mentioned decimal is 5,2. That means two decimal points will coming. So that is not wrong. If you want, like, we can keep this in this way. Let us experience how this calculation between money and decimal will go in the upcoming sessions. And I have a check constraint. I said, okay, interest rate should be greater than 0 and less than 10. So let me set it for 20. So let's get more interest rate in this from this bank. So I have said that, and I'm creating my next table. Great. The second table is created. And I have my transaction table, the third one. Transaction ID is primary key, the same way. Identity column, which will help you to uniquely identify each transactions. And I have account ID, which help me to refer to the account. Here also I mentioned cascade on delete. If I am deleting an account, it also delete that particular related transaction without writing a delete statement. Okay, so that's clear. Transaction type is what? Deposit, withdrawal, and loan payment can be captured in transaction type. So based on the transaction type, the balance is going to change. If somebody is like depositing the money, your balance would increase. If you are withdrawing the money, your balance should decrease. So that business logic need to be applied when you are going to update the like transactions in future, like balance in future. Amount, we said the amount should be decimal, or okay, let us keep the consistency. That is what something which I want all of you to think. If you are setting a data type for amount, because here you have balance, so there's a related column, so you got to keep the same data type. So that is the best practice, and I'm saying that amount should be greater than 0. Great. Transaction date, same way, we are just taking this for a logging information. Yeah, so I'll create this transaction table as well. So next activity which we have, so we have designed this table, we created this table. So we are ready with the table design. We have completed the table design. We have all this relation between the customers, accounts and transactions. So you cannot insert anything on the transaction without accounts, and account cannot be without customer, right? So we have set that referential integrity from our side. We created the ID column. So our table look like good in terms of like following these rules in this relation. Like we have relations, we did not keep the data redundancy. We also make sure that unique identify all these things, right? And we also kind of did the best data type based on our knowledge and understanding. Great. So this is all for today. On the next session, we are going to, I'll be coming with a couple of insert statements that help us to populate the data in this table. And next day, we are going to cover these, like customer still had, so we have covered these three, right? Now we have this interest calculation posting. So we need to define how we are going to do the interest calculation and how we are going to update the balance for this customers automatically when there is a transaction happen. So this is going to be interesting session. So we can expand it as much as we can, but we'll talk more about how we can apply these joins and all these things, probably like stored procedure functions and everything to get these things work. Okay, hope this helped you to think through how a table designing work on a very layman terms, how we can define like what tables and how the columns are defined, data types, relationship. Hope this video gave you a clear understanding. We'll see you on the part 2 of creating the rest of the database object for this banking application. So thank you for watching, and feel free to like, subscribe and share if you think that practical example added value to you. Thank you.